Hello and welcome. This video is to present our group assignment, which is problem-based learning for the course Algebra and Calculus. And this is the name of our teammates. So in this case, we are given a situation where we need to find the number of virtual machines that should be allocated to each department in a company. So from this information, we can understand that we are going to solve a arithmetic sequence problem where we need to find the values of each terms in the arithmetic sequence. So our first task is to determine the number of virtual machines allocated to each department. To solve this problem, we are going to use two formulas. The first one is to find the sum of this arithmetic sequence, which is Sn equals to n divided by 2 multiplied by 2a plus d multiplied by n minus 1. So we are already given the number of total virtual machines, which is 100. The number of departments is 10. Virtual machine decrease per department is 2, which will be considered as negative 2. So now, this total virtual machines is our sum. Total departments is the number of terms, which is n, and the negative 2 is our decrement, which is d. Now we already have the values for d and the sum. Now all we need to do is to find the value of a, which is not mentioned in the question. So now we're going to substitute all these numbers inside this formula. Let's write down the formula again. So our Sn is 100 equals to our n is 10 divided by 2 multiplied by 2a plus our d is negative 2 multiplied by n is 10 minus 1. Now let's multiply this. 5 multiplied by 2a becomes 10a. 5 multiplied by negative 18 becomes negative 90. So let's find out the values for 10a's. 10a equals to 100. Negative 90 becomes positive 90. So the value for 10a's is 190. Now value for 1a is 190 divided by 10, which is 90. So our a, which is the first term, is 90, which means the number of virtual machines that will be allocated to the first department is 19. Now, we are going to use the second formula to find out the pattern of this arithmetic sequence, which is Sn equals to a plus d multiplied by n minus 1. So, we had a total of 10 departments, so our n becomes 10. This n remains the same as the variable. It doesn't have any values since it is the pattern. So our a was 19 plus our d was negative 2 multiplied by n minus 1. So if we solve this, it becomes negative n is negative 2n, and negative 2 multiplied by negative 1 becomes positive 2. So to replace the number of the department with the value of n, so we need to find the second department. Now we will substitute the value of n with the number 2 plus 21. So negative 2 multiplied by 2 is negative 4 plus 21. So the second term is 17. Same goes for the rest of the terms. So after using that arithmetic sequence pattern, we already get our answers for all the 10 terms of the arithmetic sequence, which means we already know the numbers of virtual machines that are going to be allocated to all the departments from department 1 until department 10. So these are the numbers of virtual machines that are going to be allocated to every single department in the company.
Efficiency analysis. This allocation ensures departments with the highest demand receive more virtual machines. After that, departments with fewer needs receive fewer virtual machines. This optimizes resource use. A flexible virtual machine allocation strategy may be necessary for departments with varying workload.
Secondly, the part B is a geometric sequence problem where we need to find the total bandwidth need of the company after 6 months, 1 year and 2 years.
Good morning, and my name is Darinis Murugesaran, and today we're going to see the part B, which is network traffic management. So for this part, we're going to use geometric sequence formula, which is xn equals to ar n minus 1. So we already have the a and r, which is the a 10 mbps, and also the r is 15%, which is bandwidth flow rate. And the n is the label as month, now we're going to do for the first 6 months by using this formula, which is xn equals to arn minus 1. So now we do the first 6 months. X6 equals to 10, 1.15. So the 1.15 is the 15%, which is we have to change the 15% into decimal places. So 1 plus 0.15 equals to 1.15. So 6 minus 1 plus 10, 1.155. So 1.155 square is 2.01111, and the answer is 20.11 Mbps. So now we already have the answers for this first 6 months. The answer is 20.11 Mbps. Now we're going to do for the first year, which is 12 months. So the same formula we're going to use for 12 months, which is xn equals to arn minus 1. X12 equals to 10 bracket 1.15 12 minus 1. So 10 1.15 11 square. So 1.15 times 11. Oh sorry, no, 1.15 11 square is 4.65. So the answer for 12 months is 46.5 Mbps, which is 1 year. So now lastly we're going to do for the 24 months, which is 2 years. X 24 equals to 10 1.15 24 minus 1 10 1.15 23. So 10 24.89. So 10 multiplied with 24.89, the answer is 248.9 Mbps for 2 years. So by using this formula, we have answer for the first 6 months and 12 months and also for the 24 months. So that's all from me. Thank you.
After calculation, we can calculate that in 6 months the needs need will double. So a midterm I'll get to at least 20% BPS is recommended. So 1 year, the needs will quadruple, requiring at least 50 Mbps per. Lastly, after 2 years, bandwidth demand will be nearly 250 Mbps. So a long-term scalable arcade strategy is necessary. Next, efficiency analysis. First, scaling must be gradual. For example, increase by 20 Mbps every 6 months is cost efficient. Second, dynamic regression strategies can help the company to manage peak usage. Lastly, compression and load balancing techniques can reduce demand spike.